Okay, so why is Go getting so much traction? It's obviously an interesting question. Is it?
Yes.
Good, good. This is what we like to see. Yeah, I think everyone now gets that joke. So therefore, we can't have any aims, goals and objectives. There'll be far too much structure and you've got to make it up as you go along. Yeah, no, of course, Agile's been around far too long now, so it's way too passé. A bit like most JavaScript systems. So the basic idea here is really just to introduce you to why Go is getting a lot of traction, as it says in the title, because it is. In the last 6 years, I think we've basically had proof that Node is dead, so there's no point in doing JavaScript there anymore. And I hope to try and prove why. We're not supposed to do adverts, are we? Sorry about that. But if you want to do the full-on 3-day Go course, I work with these guys to do that. We also do some free half-day ones, so go and have a look at their website. We're being agile, so I have no idea where the beginning ends and the middle starts, and certainly no idea when we're going to end, except that I've lost my watch, so someone's going to have to make sure. Someone give me a 5-minute warning. I just wanted to put some context into my comments about Go. I suppose we could call these the school and university years, so that's sort of 60s, 70s type period, when Fortran was a real programming language because it was all in caps. And then we've got some UCL years where we discover that Fortran has lowercase letters in it. I was supposed to learn Clean. Has anyone ever heard of Clean? Does anyone ever do any functional programming? No. Oh, okay, so it doesn't matter that I failed to learn it when I was supposed to, which is why that's in grey. This is me spending 3 million quid of someone else's money in startups. So we keep that very small because it was a fail. Ho-hum. And having sacked 25 people at 3 minutes notice, I decided to just chill out for a while. So I learned Groovy, D and Scala because it seemed like the thing to do at the time. Poor old Fortress. These languages are going to be the other really important languages in life, the universe and everything. In my view, especially this one. And if you want to know why, you can always invite me back.
March?
Sounds good. I don't know that much C#. Now here, see, I've started doing Clojure before Go. You'll notice here there's a mix. A lot of functional programming, a lot of dynamic languages, a lot of static languages. And that's an important viewpoint on which to look at Go from. And people have probably not heard of Ceylon and Kotlin yet. Well, 1 or 2 people have. So Java is dead. But that means I can rerun another talk for a few more times. So that's really just putting my comments, and I'm always very opinionated. So I just wanted to make sure that you got a little bit of context on where these opinions are coming from. Any offers of what that one is?
SMU.
A duck. Oh, yes, indeed it is a SMU. But most importantly, it's a duck. So let's just have a few little intro points about Go. It is a replacement for C. Once you've learned Go, you will never need C again, except sometimes when you're doing stuff really low level, really small things. But most of the time, C really is gone.
So do you still need C to compile GCC so we can compile Go, or is there now a GCC
Not anymore.
and Go?
GCC Go, yes, you still need GCC.
Yeah.
But as we'll see in 2 slides' time, there's only one thing you need C for, and that's C Go, which is to connect Go to C. It's simple. Some people reckon you can learn Go in 3 hours. You can probably learn some of Go in 3 hours, but you won't get the idioms of constructing really good Go programs. That still needs a few months. Actually, any new programming language is going to take you a few months to get into. But Go is very simple. You can get into it initially very, very quickly. And they don't like C++ in Goland because it's just too complicated. And I suspect that also goes for languages like D, Rust, and any others that come along. Anyone got into Rust at all? A crucially important factor in Go is in fact Rob Pike, not necessarily individually, but individually as well. But it's because of his research programs over the years, from the sort of early 80s onwards. There was a squeak. I realised last evening I should have put squeak in here as well, and hence new squeak, which is programming language following on from it. And the important thing about all of these languages is concurrency and parallelism, where the two are significantly different. And if anyone thinks concurrency and parallelism are roughly the same, we need to talk. And we'll notice that the terms concurrency and parallelism in computing are completely different from those in natural language. You think about it. What does concurrency mean in computing? Doing one thing at once. What does it mean in real world? Doing lots of things at the same time. Yeah. I'll leave the note about Inferno for a little while. It will rise again. You're possibly asking yourself, why is Aleph in parentheses? Well, Pike wasn't a main driver of Aleph. He was a mentor on it. But the three languages nonetheless form the root to the Go language. If you go and look at the history of those languages and look at the languages themselves, they are all fascinating and interesting, but not very useful. Well, Go is, because it's the language of now. Duck, yeah. GoldenEye, yeah. You can tell it's a GoldenEye because it's got a golden eye. Actually, you also need to note that it's got a white bit there, because there are ducks that look like that have golden eyes, that don't have the white bit there.
Do you know that, Matt?
Go is very definitely native code, so there's no virtual machines involved here. It's on the metal. So it's good stuff. Object-oriented, much more object-oriented than Java, much more object-oriented than C++. In interesting ways, because it doesn't have inheritance. And most people will say, how can you be object-oriented and not have inheritance? Yeah, okay, we can have a big, long discussion about it and do the whole thing. And if you want to, okay, we could perhaps say object-based here, if you want to get sort of very 1990s about it. But, yeah, contentious point number one, really, is how can you be object-oriented without inheritance? And for me, and the reason really I started with Go and have been following it, is the concurrency and indeed parallelism that's built in to the language. How many of you guys have got phones with 4 cores? Yeah, most. How do you manage the 4 cores? You just don't care. You treat it as a device.
It doesn't behave like it's got 4 cores.
Yeah. So, you know, how many people think threads are a good idea? How many people think managing the threads is a good idea?
As a developer or a user?
the backdrop to this is again about abstraction. And computer science is supposed to be about abstraction. And we're supposed to build our abstractions and use the right level of abstraction for a given problem we've got. And yet, how many people manage stacks in their code? Nobody. You just let the compiler handle it. I mean, why care? Well, you bloody well should care. Because in a very, very small constrained system, you have to know where your stack is and how big it is at every possible moment, particularly if you're working on smart cards. You've got maybe 4K, 16K of RAM, and maybe a meg of flash. You need to know how big it is. But you guys, big systems, I don't know, big systems out here somewhere, you don't care about stack. How many people care about their heap? Oh, yeah, you just say a little bit. Okay, so in Java, you say, oh, we've got the CMS. Or if you're really up to date, you say we've got G1. Just let it get on with it. Some people care about their heaps for the same reason. Very small, constrained systems. Motor cars and things like that, they care about size of heap and things. People building on big Intel kit. So why do you care about threads? It's just more infrastructure. Just let it be managed. And that's one of the things that Go has brought front and centre to native code languages, is thread pools and having managed threads. And that is absolutely superb. Yeah, absolutely. It's a serious mongrel, this one. And I don't think anybody I know I've shown this photo to, could type that duck. It's a typeless duck. This one's even worse, because this one is clearly part mallard, part something else, and good grief, how? This is Annette's from Llangollen, whereas the other one's from London. So bizarreness gets everywhere. Storyline of Go, 2007, and notice they worked in stealth mode for a while, and then they made it public, and most people sort of cottoned on to the language fairly quickly. I think the first London Go meeting was somewhere around here, and that was good fun. And somehow Go meetings always get pizza and beer.
We normally get beer, to be fair.
I don't know. I actually know who funds it. More on that in a moment. Clearly, it wasn't until this point that it became acceptable for businesses to use Go, because nothing about a language matters except the version number. And the point someone was making earlier, do you need C to compile Go? No, because it's now a self-hosting system as of version 1.5. So Go is written in Go, which means you need a bootstrap, which means you need 1.4 to build 1.5 and so on and so forth. But that's a sort of standard evolution of a programming language.
What sort of duck is that?
No, this one's definitely a squirrel, and it's definitely saying that the bird feeder is empty. Feed me. I think you can tell that by the sad eyes and the plea of feed me. I'm heartless, I tend to ignore them, and they tend to not like me after that, as you can tell there. But what is it that sort of engenders like and dislike? How does one actually become popular in these games of programming and programming languages? Has a lot to do with it. That's marketing. Perhaps the single most important thing in pushing a language is you get early adopters who were influential. And the Go guys did exactly that. They went out and got some well-known people to talk about the language. And you've got to create a bit of a bandwagon for any language. C did it over a period of years in the 70s. Go's managed to do it in about 2-3 years. There has to be an interesting reason why that has happened. And actually, I think it's probably slightly more technical than non-technical, that the speed of adoption has happened. That Go has got appealing features. Many of them relate into that concurrency and simplicity. But also, it is replacing C and, to a great extent, some C++, some Python, some Ruby. So I think if you put those four together, you've got the beginnings of the reason why the Go bandwagon took off so quickly and so deeply. Part of Google's aim here was to solve their own problems internally. They have a lot of different languages in there, and they have a lot of C and C++, and they were having problems. I don't know how offhand the comment was, but someone was saying, from one of the Google team was saying that the problem was that they've got so many interns that can't program massively well, that they need a language that they can program well in. It sort of sounds about right somehow. So I think there's a grain of truth in that. So the simplicity in Go is there to make sure that interns can't screw things up on the Google code base. And how many people actually understand C++? I think Jonathan Wakely is probably the most knowledgeable person I know in C++, and even he gets it wrong sometimes. It's a truly complicated language. And C++ has only just got threads in the language, only 15 years behind Java. But that's not real proper ongoing concurrency. So, yeah, that's what Google needed, was a handle on the concurrency for their big data centers. They also did something which was really very, very smart and nothing to do with the technicalities of the language. They actually went out there and told people about it and gave them free beer and pizza and cuddly toys. The cuddly toys are crucially important. You can get the blue one, the pink one, and the purple one. And I've got 2 blue ones and a pink one. I managed to miss getting the purple one 2 weeks ago. Really annoying.
Show my age now. What's a toady?
A groveler.
Okay.
Person who joins a bandwagon because someone rich and famous joins a bandwagon. They are surprisingly important people when you're trying to make stuff popular, because they create numbers, they create noise out there, and they get your ratings up on stupid indexes like TOB, which has sad influence, even though it's gratuitously silly number. But this one, I think, was the master stroke. Having got a simple language, having got some contentious features in it, they shouted it to the world and said, come and argue against us. And boy, they did. And that created publicity, and that created knowledge of the language, because everybody said, oh, they're arguing about this. There must be something interesting in there. And that's a really interesting way of getting stuff done. There's deep marketing going on there. So you might argue that the success of the technology is more about the marketing than the technology itself. And yeah, there is some truth to that. If it hadn't been for the marketing that Google funded, Go wouldn't be where it is now. But likewise, if they hadn't got some particular individuals involved who guerrilla-like got the technology into production, it wouldn't have had the base of good product out there that people could use as exemplars. Don't you just love how this particular animal is so well adapted to life in the trees? The colour, well, apart from the orange legs. SAS duck. So, contentious point. Go is a systems programming language that has garbage collection. Now, everybody in Modular 3, what was the programming language? They wrote an operating system in it about 30 years ago. Inferno, they've got a virtual machine in there. So it's not on the metal. It's not. I think that's the important thing that Inferno's got to say of that Pike sequence, is that actually you don't have to be bare metal to be doing systems programming. And do you need bare metal to write an operating system? It's an interesting question. It keeps coming up on the list, the Go list, and no one's actually tackled it as yet and written a full-on operating system in Go. But it will happen and it will work. We know it will work because Inferno worked. We know it will work because the experiments using Modular 3 to write operating systems worked. It's just that they didn't get marketed, those two, as well. The whole Plan 9 thing and Inferno didn't sell into the market. There are no generics in Go. This causes amazing fights. I think every 2 months someone says, oh, I've got this new way of doing generics in Go. I say, yeah, we've heard it all before. They just haven't gone back in the mailing list to see why the idea will fail. And fail it will because it doesn't match the simplicity level. That's the fundamental thing. Most generic systems have type systems that are too complicated for Go's way of thinking of things.
So does that mean there's more verbosity then?
There's certainly more duplication of code.
Okay.
So if you want something of ints and something of floats, you have to have it twice. But there is a nice trick for handling that. Do we get an R? We've got little babies. This is a red-breasted merganser, in case anyone didn't know. You can tell it's a red-breasted because it's got a red head. And the males have a green head. But pictures of little baby ducks always get an R. Well, except when they're doing something like that. So why all this? Well, it's obviously down to duck typing. The success of languages like Python rest on doing duck typing. And I think that works as a definition. Just looking around, see if people think that's a reasonable definition for duck typing. It's all about runtime. You don't care about compile time. Now, a lot of people, programmers who are used to strong static type languages, can't cope once you give them a dynamically typed language. I mean, literally can't cope. And that's sort of quasi-understandable, but it would be better if they just got on with it and learnt the difference between static and dynamic typing, because they are completely two different mindsets. You can't use one mindset with the other language. That's when failure happens. You've got to use the static mindset with static language, a dynamic mindset with a dynamic language. But it's not a problem. You've just got to use the right mindset at the right time. But Go's actually slightly confusing the issue. Following on from our camel, we're using structural typing. And it really basically means programming to interfaces. That's a more formal way of thinking about it, is structural typing. And structural typing and duck typing have some subtle interplays. They are different things, because duck typing is all about doing things at runtime, but programming to interfaces, structural typing, allows you to do compile time checking. mostly. And Go has that one case where it actually has duck typing in there. And that really gets people worked up. And getting worked up is great because it creates marketing, creates publicity, and people moan about it. But this is, I think, the one place where it's going to take you 3 months to really learn Go, is to deal with this competition between static and dynamic, but also structural versus duck typing. We'll see some examples in a minute. I already had a bit of a rant about the concurrency and parallelism and the explicit management, so I did that a bit too soon. I should have waited till we got this slide. But it comes down to who's using thread pools. Java's using thread pools. I'm sure C# must be using thread pools by now. Well, C++ might catch up in another 15 years. Everybody's using thread pools as the first port of call for dealing with concurrency. And oh no, hang on a minute, no single threaded. They've missed the boat. Oh well. So I thought we need some code by now. So I've only got one example. I've been using it for 8 years. So seems like a good idea. Have you noticed how these wonderful creatures understand pi? Marvellous. Okay, so we want to calculate pi, and whoops, what's happened here? Wrong, something's gone wrong. Panic. We need some font size. Is that?
Can't do this language, the braces are in the wrong place.
There's one thing you do know about Go, is that the braces are always in the correct place. Originally, to much controversy, the Go compiler would read your code, decide whether it was in the right format, and if it wasn't, it would write it back and then compile it. That was an interesting period. And then the compiler writers relented and said, no, the compiler's not responsible for doing that. Go format is responsible for doing that. And so we get the Go format tool, which informs your code how it should be formatted and writes it back. And quite right too. So the curly brackets are in exactly the right place. If anyone thinks it should be on the line below, you are wrong. And there is no question about it, because Go format will tell you. Like it or lump it, Go format is actually very good, because every Go programmer on the planet uses exactly the same format. There is no bike shedding. You just have to lump it if you don't like it, or use another language. Okay, so lots and lots of type inference going on here, and so it should, in this 2015s, any language that doesn't do full type inference is wrong. So that's Java gone. But Go is completely fascist when it comes to having the type correctness of operations. It just will not compile things that require, in other languages, implicit changes of type. Okay, so it's code is code, it's C-like. As I say, you can probably learn most of this level of Go in 3 hours. Oh, I suppose I should just indicate that this is a definition and an initialization. So if you wanted to write it as var start time equals, you could do. You probably have to put a type in here as well. But nobody does. Everybody just uses the colon equals as definition and initialize.
So how is that different from the const delta above?
Because this is a variable. So you can update its value.
Constant. Oh, okay.
Whereas this is a binding,
So
one-time
you
binding.
can't just do delta equals whatever then?
Not with the const there, no.
No, I mean without the const. You can't do it without the const.
Oh, if I take that const out,
Yeah, so that's still
you'd have to put a colon in there. However, the sequential version is not very interesting. The reason for showing this example is to have a look at one of the most important features of Go. Whoops, too soon. Is that some font size? Is that about right for font size? Yeah, cool.
Sorry, is a new line statement delimiter? Because I noticed there's no semicolon.
There are no semicolons because they get inserted on the way in through the compiler. So the compiler checks to see where the semicolon should be and then puts them in. It's a bit like Scala does that as well.
So I don't get choice about the brackets as well.
Well, yeah.
There are interrelationships between those things, yes, absolutely. And it's why you have to have else's in certain places. So here we are. That's it. The one and only tool for doing concurrency and parallelism. And it's all you ever need. You just spawn off a task. It goes into the task pool and is part of the task pool that gets handled by however many threads you suggest. Go 1.4 and earlier, the default was 1. In Go 1.5, the default is supposedly the number of processors reported by the operating system. I'm having some doubts about the relationship between processors, cores, and Linux, because this is supposed to be 4 cores according to Linux, and it's clearly 2 cores with hyperthreads. Anyone who's done any benchmarking of cores with hyperthreads will know that hyperthreads are a waste of time on most jobs. Not all, it can be good, but on most heavyweight computations like this, it's a waste of time. However, that was a completely irrelevant side comment. So what are we doing? We're just saying I want some number of threads in the thread pool. And then we make some channels. If you want to think about them as thread-safe queues, that's a good start point. It's not a good finish point. You need to think about a bit more about them. But as a good start point, they're thread-safe queues. And so we make a thread-safe queue that is going to handle floats. Nothing else. You can't put anything else down there. So strongly typed. And then we get, I don't like for loops like this, but it's Go, so you have to have them. Simplicity is only one way of doing it. Oh, and don't try putting ++i either. That'll be a compile error. But then we spawn off this job up here, and we're giving it a channel. So we send into the subprocess the endpoint that it's going to feed in, exactly as you would with queues. 5 minutes, I better hurry up. There we go, here we've got a channel. We are sequential code. That is actually really rather important. By having a strong model of concurrency, most of your code looks and is sequential code. And programmers are beginning to be really quite good at writing sequential code. Concurrent code's still a problem. So a strong model of concurrency, really important. And that's what we've got here. We send out on a channel, we then receive on the channel. All of the coordination, all of the synchronization is about the data traveling down the channels.
So assuming you can't guarantee the order in which the floats are baked into the channel?
In this particular case, no, but we don't actually worry too much about that. If you need to do that, there are easy ways of handling it. Another quick example. I do a lot of networking, mostly between my computer and my amp, because my amp has, well, Arcam told me it had. Actually, it doesn't. have a way of controlling the AMP from the internet. And so here I'm trying to just write a client to it. No, I didn't want to show the client, not with this little time to go. I will show the actual, I'm making a mock of the RCAM because I don't want to carry an AVR 600 around on the train. I want to be able to test my code without having the AMP. This sounds like a damn good idea for a mock, so I'm writing myself a mock AVR. And we get to use all the fun stuff like structs. We like structs. Do you like structs? Yeah, good way of putting datas together. And we can do interesting things with maps. So if you want a map, you just have a map. It's primitive data structure. And we can create instances of these and values and so on and so forth. And then we can have some functions. This is not a very interesting function. But further down, we get some interesting functions where it's gone away. So let's go over here for a moment into protocols, because the mock is just a consumer of the protocol package, and so is the client. It's just organising the code into packages. You do that for Java, C#, any other programming language. I just need the actual, let's do command code. So I've got a lot of command codes that you can send down. This is an enum done properly. So, okay, they're implemented as bytes, so when they're going to be bytes down the line, but we are going to have a type command code, and command code is not a byte. It's a type that's implemented with a byte. And so I've got all of these. It's now an enum. Yeah, great stuff. What happens if I want to output a string representation of the enum? Well, you have a tool for doing that. Go generate. And this comes back to the point about making int and float copies of things. You can actually do interesting things with go generate, which is a prephase which writes source code based on tools. And that's an important message that came from the Go format. The compiler should do its thing, and then there should be a whole load of tools around it. Given time, I'll skim a little bit over that and draw to a close. If anyone wants to have a look at the code and go, yeah, or something like that at it, they're most welcome. The problem for me is that the AVR 600 doesn't work properly. You have to get the AVR 700 or the AVR 900. And as you can tell, the numbers got bigger, so the price got bigger.
Okay, not cheap anyway.
Well, that's true, but I was rich when I bought it. And then I ran out of money. Yeah, okay, these are some little rants about programmers. And a sort of gratuitous squirrel. Completely gratuitous. There's absolutely no reason for this one at all. There's plenty of reason for this one, because did you vote for Bob? No, if you didn't vote for Bob in the election, I suggest you go to the Vote for Bob website and have a look at why squirrels of all sorts have a bit of a problem. And so do ducks. And so do most living things in the UK at the moment. However, Go is simple. You can learn it to use very quickly, but to use it sophisticated and idiomatic takes a little bit longer, because some of the choices that have been made are very different, and there's lots of controversy around the language. But the controversies, in the end, just go over the heads of the development team, because they are happy and confident with the way that Go is going. And it has been well marketed. I think you put those three together, and it goes a long, long way to explaining why Go is getting this much traction. And it is getting a lot of traction. Cloudflare, SoundCloud, all of these folks are basing their businesses on using Go, getting rid of PHP, getting rid of Ruby, getting rid of Python, and putting everything into Go. And I will leave it at that point, which I hope is about only 30 seconds over time.
Yeah, close enough. Thank you, Russell.